Now what I used to do is I would like to use integration by parts. Now in this case it doesn't matter which term you take it as u. You can take either u to be as sin x or u to be as e raised to the power of negative ux. So what I wish to do, I would like to take the differential and the integration term in this fashion. Now since it involves trigonometric function, it be successive differentiation and integration. So we need to be prepared for that. So this entire term is equal to, I'm going to place the terms here. So I'm going to start off with e raised to the power of negative ux as the differential first term and sin x to be the integrating term. Now if you were to differentiate e raised to the power of negative ux, you get e raised to the power of negative ux. Since the variable is x, the constant is negative u, so you place the negative u there. Now you were to integrate sin x, you get negative cos x. Now you differentiate e raised to the power of negative ux, there is a negative sign. So that would mean we'll have a positive sign, and constant is u is multiplied here. So that would give us u squared, followed by the differential of e raised to the power of negative ux. That's going to be e raised to the power of negative ux. And integrating negative cos x would give us negative sin x. So there isn't any much change with reference to the sign. So we start out with the positive, and then we have a negative, and then we have a positive. So if I were to write all of this terms in uv negative integral v du form, so I start with this and then follow it up with this, and then I place this as the integrating term. So this is going to be e raised to the power of negative ux times cos x. So there is a negative sign there, followed by negative positive times negative, that's going to be negative, and then u times e raised to the power of negative ux times sin x, followed by positive into negative, that's going to be negative u squared e raised to the power of negative ux times sin x times dx. The integral sign is actually stretching from 0 to infinity. Now on the left I've got this, so I need to move this to the left hand side. So if I had to move this to the left hand side, I would get integral 0 to infinity sin x e raised to the power of negative ux times dx positive u squared e raised to the power of negative ux times sin x times dx, limits are 0 to infinity, is equal to negative of, in fact I could have taken e raised to the power of negative ux, anyway it's okay, e raised to the power of negative ux times cos x. If I were to take negative out, this is going to be positive of e raised to the power of negative ux, there is a u there, so place the u, times sin x. Now u squared is actually a constant, so it can come out. If it comes out, this is going to be rewritten as, because if I were to take 0 to infinity, e raised to the power of negative ux sin x times dx, I would have one positive u squared over here as a scalar quantity. This is equal to negative e raised to the power of negative ux, right? So probably in the next step I will take that down. So times cos x positive u times e raised to the power of negative ux times sin x. So what I wish to do is I would like to take this quantity out, e raised to the power of negative ux out, right, and then write this as cos x positive u times sin x. I can move this down, so this is going to be 1 positive u squared, and on the left I got 0 to infinity e raised to the power of negative ux times sin x times dx. So this is what I have got. If you were to substitute the limits, say 0 to infinity, I can just show that to you. So when x is tending towards infinity, e raised to the power of negative infinity times x, this entire quantity is going to be 0, right? As I mentioned to you, e raised to the power of negative infinity will tend to 0. As x tends to infinity, this quantity will be tending towards 0. So the upper limit is producing 0 followed by negative of negative. So if I were to have a negative of negative, this is going to be a positive quantity, right? Upper limit minus the lower limit. So my lower limit is this. Now if I were to set x to be tending towards 0, what happens when x tending to 0? So this is going to be 1, this is going to be 1, this one is going to give me 0, right? Because x is tending to 0, this is off, and this is divided by 1 positive u squared. So what would this happen? I mean, what would this lead us to? This negative of negative is going to be positive, so you would have 1 over 1 positive u squared. So this is the solution that we would get.